Often, when we talk about the failures of artificial intelligence, it's because it's doing something that's patently unfair. This could be something patently egregious, like not recommending that African Americans be given bail, or something that in comparison is relatively minor, like not detecting non-white faces in a photo. When these things come up, a common response is that these algorithms aren't biased. Sure, AI is a tool that can be misused, but you actually have to go out of your way to do harm because algorithms are intrinsically fair. Such a statement is both superficially true and dangerously naive, because while the tools are indeed not designed to be evil, they overlook the elephant in the room, and AI isn't just the code and the equations that define it. Indeed, those abstractions are useless without the real building blocks of modern artificial intelligence: data. And that's the thing. Most of our data come from the real world. And as my daughter will scream every time she loses a game of chess, the real world ain't fair. If you learn whom to approve for a loan based on historical data, you'll recapitulate laws that explicitly ban Jews and African Americans from living in particular neighborhoods. This is summed up particularly well in an opinion article by Jens Ludwig and Cass Sunstein. The Achilles heel of algorithms is the humans who build them and the choices they make about outcomes, and the training sample. Algorithms change the landscape. They don't eliminate the problem. And even if you exclude a variable like race from your algorithm, that isn't a solution to this problem. There are other variables that you didn't exclude that are highly correlated. The zip code you live in, the job you have, where you went to school, and so on and so on. In the legal system, there are two main ways of thinking about bias: disparate treatment and disparate impact. Disparate treatment focuses on the process. A decision is unfair if it took, say, gender into account to only give a leg up to one group. On the other hand, disparate impact is unfair if there are harms or benefits focused on a particular group. And for supervised learning approaches, you can explicitly measure these properties and create machine learning metrics that match these ideas. Statistical parity measures means that you'll approve a loan for group S and group T with the same probability. Alternatively, with equalized odds, you can measure the error that you get on group S and group T and assure that these error rates are similar. But just having these measurements isn't enough. Groups need to actually be represented in the underlying data sets to ensure these properties could actually be measured with any fidelity. But that isn't always the case. If your data set lacks representation from diverse groups, you won't even know if you have a problem. Here's a model, and unlike usual, I'm not going to post the titles and authors because I don't want to pile on. This model takes a pixelated image and tries to guess what the original image is. And it can do things like tell you what the protagonist of Wolfenstein 3D looks like in a non-pixelated form. That's pretty cool. But what if you ask about a non-white person? Take these original images, downsample them, and then ask the model to recreate the original image. Yeah, not so great. They all turn into white people. Not so cool. I work on natural language processing, and this subfield of artificial intelligence is not immune to this either. First, there's the issue of language. We mostly work on English since that's the language of science and the British Empire.
He remains an Englishman.
That in and of itself introduces quite a bit of bias in the sorts of things that we even talk about. For example, we're going to have much less coverage of, say, gamelan instruments compared to looking at a corpus in Indonesian. But even within the language we gather to feed into rapacious language models, whether we get it from books, newspapers, Wikipedia, or the wild, wild web, reflects the society that we live in. And that is a society where most doctors are men and most professional basketball players are African American. Models that learn representations of text absorb these trends and recapitulate the intrinsic biases in text data. For example, in this paper by Jieyu Zhao, currently a postdoc at the University of Maryland, You can look at the word embedding of an occupation and see whether it's closer to the embedding of a man or a woman. And there are clear correlations between occupations and the representations. And the same sort of bias has been observed in other natural language processing tasks like coreference resolution and machine translation. And this isn't just a problem of tweaking algorithms or curating data. The only way to really solve this is to make sure that there's representation among the people creating and deploying artificial intelligence algorithms in industry and in academia. And that's not happening, neither at companies nor in universities or in the government. And I mentioned that last category because I suspect that many of these problems are only going to really be addressed through legislation or regulation, not good intentions. And this necessary change can't come soon enough because we sure as heck haven't solved these problems, and they're becoming even more salient as artificial intelligence becomes more widespread in society. This is just a single lecture from a course. YouTube likes to show you these videos out of order, but if you go to the course webpage linked below, you can see the lectures in the right order, and you can get resources like homeworks or suggested reading. You can also visit quanta.org if you want to learn about our systems for creating computers that can answer questions, where Quanta stands for question answering is not a trivial activity. If you want to help the channel, provide a big gradient to the algorithm by liking and subscribing.